Microsoft is investing billions in nuclear power, not for climate goals, not for sustainability, but to run AI. Because training and operating modern AI systems requires a constant flow of electricity at a scale most power grids simply can't sustain. And this raises a question. Why would a tech company need nuclear energy just to keep AI running? And more importantly, what happens if they don't get it? Because if AI depends on energy at this scale, then this isn't just a technology problem anymore. It's an infrastructure problem. And the companies that can't solve it won't be able to compete. AI is often described as a software revolution. Better models, smarter algorithms. But that's not what's actually limiting it. Because every improvement in AI comes with one hidden cost: more compute, more infrastructure, and most importantly, more power. This is not about building better AI. It's about who can afford to power it. And this is where the system starts to break. Because the demand for continuous high-density electricity is growing faster than the energy systems designed to supply it. Which creates a new question. Who actually controls that energy? And if access to energy becomes limited, who gets locked out of AI? AI is scaling faster than any infrastructure built to support it. Companies like Microsoft, Google, and Amazon are deploying massive data centers filled with thousands of GPUs, each consuming significant amounts of electricity. As demand for AI models increases, these data centers must run continuously, processing data without interruption. This is not occasional usage. This is constant, industrial-scale consumption. And as more companies adopt AI, the total energy demand grows exponentially, which creates a direct consequence. The more AI scales, the more energy becomes the limiting factor. The problem is not just how much energy AI uses, it's how it uses it. AI infrastructure requires stable, uninterrupted power, 24 hours a day, 7 days a week. But electrical grids are not designed for this type of constant high-density load. They fluctuate, they depend on demand cycles, they cannot guarantee continuous supply at the scale AI requires. Renewable energy makes this worse. Solar and wind are intermittent. They depend on weather conditions, which creates a structural constraint. AI cannot rely on unstable energy sources, and this leads to a hard limit. Without stable, high-output energy, AI cannot scale reliably. Solving this problem requires more than technology. It requires capital. Building or securing nuclear energy infrastructure costs billions of dollars and takes years of planning, licensing, and construction. Only a few companies have the financial capacity to make these investments. And they are already doing it, which creates a new barrier. Access to energy becomes access to AI. Most companies are locked out. They cannot afford the infrastructure. They cannot secure long-term energy supply. So, while AI appears to be open and accessible, the reality is very different. The companies that can fund energy infrastructure will scale. Everyone else will be left behind. At first, it looked like I was a software race. Build better models, train on more data. But that's not what defines the winners anymore. Because the real limit is not compute. It's energy. And energy at this scale is not widely available. Only a handful of companies can secure stable long-term power, which means they don't just run AI. They control who can scale it. AI is becoming an infrastructure game. And infrastructure requires capital. The companies that can invest billions into energy, data centers, and long-term supply will keep scaling. Everyone else will hit a wall. Because in this system, access to power defines access to AI, and access is not evenly distributed. Money creates access. Access creates control. And this is the industry code.